I said in the last video that I don't like the cofactor matrix inverse formula so much, that I'd rather use row reduction. But then I thought to myself, for a 2 by 2 matrix, it's not that bad, and maybe it's even better than row reduction. So let's try it and see. Let's invert this general 2 by 2 matrix, A, B, C, D, assuming that it's invertible. That is, assuming that AD minus BC is not equal to 0. So the determinant is AD minus BC. Now we compute the cofactors. So we've got plus something, minus something, minus something, plus something. So the signs alternate like a checkerboard. And we start with the 1, 1 position, cross out its column and row, and we get D. Then we go to the 1, 2 position, cross out its column and row, and get C. Cross out this column and row, and we get B. Cross out that column row, and we get A. So each time we're doing a 1 by 1 determinant, which is easy because we just copy down the one number there. So we've got this matrix, which is D minus C minus B, A. And then we transpose this to get, let's see, 1, I'll write this a little bit lower so we can check it. 1 over AD minus BC, D negative B negative C A, because I'm transposing what's there, so the negative B and negative C switch. So this should be the inverse. Now let's check it to make sure I did that correctly. So let's write A, B, C, D here and see what happens when I multiply these. So I've got AD minus BC, BD minus BD is 0, negative AC plus AC is 0, and then negative BC plus AD is AD minus BC. Now I did this multiplication ignoring the 1 over AD minus BC, but of course if I divide this matrix by 1, if I multiply this matrix by 1 over AD minus BC, you see that I got the identity matrix. So this method does work. So, I mean, well, obviously the method works, but I'm trying to say I did it correctly right here. So let's look at this matrix we get. So we just decided that if AD minus BC is not equal to 0, then the inverse of this 2 by 2 matrix, whose entries are A, B, C, D, is given by 1 over AD minus BC. So we switch the D and the A, but keep their positive signs. And then we keep the B and the C exactly where we are, but we switch their signs. So if we can remember that, 1 over determinant, switch the two diagonal entries, but keep their signs. And then keep the two off diagonal entries where they are, but then switch their signs. Then that could be an easy way to come up with the 2 by 2 determinant without having to do row reduction. So in this case, I think I would recommend the cofactor method of finding the matrix inverse. The end.